Again, more problems on De Morgan's theorems. Yesterday we take 2 problems. More problems. Prove that 1 plus I is 2 power 6 1 minus I root 3 is 2 power 4 upon 1 minus I is 2 power 8 and 1 plus I root 3 is 2 power 5 equals to answer I upon 4. Okay. So this 4 complex number 1 plus I 1 minus I 1 plus I root 3 1 minus I root 3. So these numbers expressed in polar form. First of all, because De Morgan's theorem depend on polar form. So every numbers must be in polar form. So express polar form, polar form. So first of all 1 plus I. Okay. So 1 plus I polar form r cos theta plus I times r sin theta. Then equating real and imaginary parts both sides. So left side real part 1, right side real part r cos theta. Imaginary part means I multiple, nothing means 1 is there. So again 1 imaginary part, here imaginary part r sin theta. Okay. Next step, squaring and adding, because cos square theta plus sin square theta is 1 trigonometry. So next step we know is squaring and adding. So left side square 1 square 1, right side square r square cos square theta. Second equation 1 square 1, right side square r square sin square theta. Addition also. So 1 plus 1 2, right side r square common, then addition there cos square theta plus sin square theta, that is 1. So r square. So r square is 2. Therefore r will be root 2. Okay. Now theta, put in 1 and 2, this value of r, put in equation number 1 and 2. So 1 equal to r means root 2 cos theta. From this, then what will be cos? 1 upon root 2. Second equation, again put r equal to root 2 sin theta. So from this we get sin theta is again 1 by root 2. So sin and cos both 1 by root 2. Where angle is 45 degree. Only sin and cos are equal. Only when angle is 45. 45 means pi upon 4. Okay, so we get value of r and we get value of theta also. Therefore, this 1 plus I complex number becomes r root 2 cos theta plus I, r is in root 2 sin theta. Theta now also we have to put pi by 4. Pi by 4. Or this is same as root 2 is common. cos of pi by 4 plus I sin pi by 4. Okay, 1 plus I. Similarly, 1 minus I. Similarly, same. In place of plus only minus, others are same. So cos of pi by 4 minus I sin pi by 4. Okay. So this for expression for 1 plus I and 1 minus I. Now same technique for 1 plus I root 3. 1 plus I root 3. Same r cos theta. Now we take r1 suppose. Already r cos theta. So we take now r1 cos of theta 1. I times r1 sin of theta 1. Same step. Okay. First step is equating real and imaginary parts. So real part 1 r1 cos theta 1, imaginary part I multiple root 3 r1 sin theta 1, third equation, fourth equation. Squaring and adding, squaring and adding. So 1 square 1 r1 square cos square theta 1 root 3 square 3 r1 square sin square theta 1, also addition. Same step. So 1 plus 3 4 right side r1 square common, addition cos square theta 1 plus sin square theta 1, that is 1. So r1 square into 1, that is r1 square. So r1 square is 4, therefore r1 is 2. Okay. Put this value in question number 4 and 5. So 1 equal to r1 means 2 cos of theta 1. So from this cos of theta 1 will be 1 by 2. Then similarly second root 3 r1 is 2 sin of theta 1. So sin theta 1 will be root 3 by 2. So when sin is 1 by root 3 by 2, 60, and cos will be half 60. So theta 1 will be 60 degree. 60 means pi upon 3. Okay. So therefore this your complex number 1 plus I root 3 will be. So r1 is 2 common, cos of theta 1 is 60 pi by 3 plus I sin pi by 3. So 1 plus I. Similarly 1 minus I, in place of I minus I, cos of pi by 3 minus I sin pi. Okay, so we have explained to both the complex number. Out of 4 only 2 are similar. Now your answer comes to. So I want to answer for 1 plus I raised to power 6, 1 minus I root 3 raised to power 4 upon 1 minus I raised to power 8 and 1 plus I root 3 raised to power 5. So 1 plus I, 1 plus I is, I think, root 2 times cos of pi by 4 plus I sin pi by 4 space. So 1 plus I is root 2 cos of pi by 4 plus I sin pi by 4 is to the power 6. And this 1 minus I, 1 plus I, 2 times cos of pi by 6 minus I sin pi by 6 is to the power 4 upon 1 minus I plus and then minus cos of pi by 4 minus I sin pi by 4 is to the power 8. 1 plus I root 3 plus 2 cos of pi by 3 minus I sin pi by 3 is to the power 5. Simplify. Okay, apply De Morgan's theorem or also Euler's theorem. So root 2 raised to power 6, root 2, 2. Okay, 2 raised to power 8, 3. Root 1 by 2 raised to power 6, 1 by 2 is 2 raised to power 3. So cos of De Morgan's theorem or Euler's theorem also we can use. Euler's also. E raised to power I pi by 4 shortly raised to power 6, 2 raised to power 4 e raised to power minus I pi by 3 and raised to power 4 total. Here root 2 raised to power 8, root 2 is 1 by 2, 2 raised to power 4. This is e raised to power Euler's theorem, e raised to power minus I pi by 4. It is 2 raised to power 5 e raised to power I minus I pi by 3 and raised to power 5. Okay. So first of all 2 raised to power we have it. So 2 raised to power 4, 2 raised to power 4 cancel. 2 raised to power 3, 2 raised to power 3 cancel, is 2 remaining. So only 1 by 2 square and 4 remaining. Now e raised to power total, what is e raised to power? So e raised to power I 6 into this, 6 into pi by 4 is e raised to power minus I 4 into pi by 3 is here e raised to power 8 actually. So e raised to power minus I 8 times pi by 4 and this e raised to power minus I 5 times pi by 3 total e raised to power. Now see e raised to power total 1 by 4 outside. So e raised to power 3 cancel, 3 by 2 e raised to power I 3 pi by 2 here e raised to power minus I 4 pi by 3 here 2 cancel and comes to numerator I take e raised to power positive I and it will be 2 pi only. 2 pi only. This again comes to numerator e raised to power positive I 5 pi by 3. Okay, so all e raised to power numerator index law. Now we add total e raised to power I pi also common. E raised to power I pi is common total. So here 3 by 2, here minus 4 by 3, here 2 pi, and here I pi by 3. So pi coming here, no pi, only 2 here, and here I pi by 3. 1 by 4 e raised to power I pi. I take 3 by 2 same, 2 same, 5 by 3 and 4 by 3, 1 by 3. 5 by 3 minus 4 by 3, 1 by 3. Now 3 by 2. Only calculations, plus minus, minus, only one minus, this plus, 5 plus, plus, plus 5 by 5, plus is here now minus. So 4 by 3 and 9 by 3. 9 by 3 is minus 3 actually here. So 3 by 2 minus 1. 3 by 2 minus 1 only now. So 3 by 2 minus 1, 3 by 2 minus 2, 1 by 2. Okay, this one to take. So plus. Okay, so raised to power 90. So 1 by 4 e raised to power I pi by 2 we require. Okay, now convert to sine cos again. Euler's formula and De Morgan's theorem both. So convert to now sin cos e raised to power I theta cos 90 plus I sin 90. Euler's formula. Cos 90 0, sin 90 1. So this I. So I by 4 answer. LHS or okay, so convert to polar form. Every problem is first of all convert to polar form. Then we can use De Morgan's theorem or Euler's formula. If 2 cos phi equals to x plus 1 by x, then show that 2 cos of n y, then x raised to power n plus 1 upon x raised to power n, and second twice I sin ny minus addition cos, subtraction sin. Okay, problem of De Morgan's theorem or Euler's formula. Okay. So given to you 2 cos y, then x plus 1 by x. So x plus 1 by x, LCM x into x square plus 1, x multiply left side. So 2 cos y into x equals to x square plus 1. So take one side. So x square minus 2 cos y into x plus 1 equal to 0. Okay, so this is now your quadratic equation. Their roots not directly. Okay, real numbers are some complex number because 2 cos y not a number. Okay, formula is formula minus b plus or minus b square minus 4ac upon twice a. What is formula? Minus b, and b value is minus 2. Okay, minus b and b value is minus 2 because minus here is maybe mistake. Plus or minus under root of b square minus 2 square 4 positive also square y minus 4ac. A is 1, c is 1, y is a. So minus plus 2 cos y from the under root of 4 is common, means 2 will be outside the root. Remaining cos a square y minus 1 by 2. Two common, cos y plus or minus 2 common, cos a square minus 1 minus sin square. 1 minus cos a square sin square. Cos a square minus 1, so minus sin square. So 2 cancel. X will be cos y plus or minus. So root of minus 1 I and root of sin square sin y. So this like this. So x equals to cos y plus or minus. So I take one of them. Let suppose say positive. X is cos y plus I sin y. This is in the inverse formula e raised to power I y. If you use inverse formula, use e raised to power. Otherwise, de Morgan's formula. Okay. Now you are first. Okay. So I want x raised to power n plus 1 upon x raised to power n. First result. X raised to power n. This same as x raised to power n plus x raised to power minus n. 1 upon n is x raised to power n. So cos y plus I sin y raised to power n and minus n, same x cos y plus I sin y raised to power minus n. I use de Morgan's theorem. Raised to power n cos of n y plus I sin n y. Here cos of minus n y plus I sin minus n y. Here we use DMT, means de Morgan's theorem. Both. Now solve. So cos of n y plus I sin n y as it is. Cos of minus s, cos of x, same. So cos of n y only. And sin of minus x is minus times sin of x, trigonometry. Okay. So I sin cancel. Cos plus cos now 2 cos of. This first answer. x raised to power n plus 1 upon x raised to power n will be this. Now subtraction. Wait a second. X raised to power n minus 1 upon x raised to power n. X raised to power n minus x raised to power minus. Now subtraction there. Same. These two steps are. So cos of ny plus I sin ny minus cos of minus ny plus I sin of minus ny. So cos of ny first term same. Open the bracket minus cos of minus ny, cos of ny positive same, and this minus sin of minus ny is minus times sin of ny. Now cos is cancelled, so I sin ny and I sin ny is twice I sin ny. So subtraction in terms of sin, addition in terms of cos. This will be your second answer. Hence, both the answer.